In today's video, we are gonna look at random forest classification. This is like an hello world for our machine learning project. If you are trying to understand AI and machine learning, random forest is like most suitable algorithm to start with. And surprisingly, this algorithm fits almost everywhere. Before moving forward, let's try to understand the type of data we are going to use for random forest. We are going to use iris dataset for our random forest classification project. This dataset has around 115 stances of three different types of flowers from iris category. Those flowers are setosa, versicolor and virginica. Predict to which category each flower belongs to, we will be using four features of the flowers. Those are sepal length, sepal width, petal length and petal width. More detail on this data can be found on UCI machine learning repository website, who is the owner of the data, and how this data turns out to be, how many instances, and many more details can be found here. But we will avoid the technical details here. We will directly jump into our code. To save time, I have already created a skeleton program which we are going to use in this project. Before moving forward, we will import all the necessary libraries which we are gonna need it for this project. And the good news is that we don't need to download the data externally, because this data is already present in our sklearn library. If you have not installed sklearn library, you can directly use pip command to install the sklearn library. It's a very important library to move forward with. So if you are planning to be a data science engineer, you need to have this sklearn library installed and have a in-depth knowledge on this library as well. So let's move forward on this. First of all, we are gonna import all the necessary libraries. We are gonna need pandas, sklearn ensemble and random forest classifier, which is eventually the soul of our project, this random forest classifier. Then we are gonna use trend test split. This is very crucial part, because if we have a certain amount of data, we have to split it into train and test category. This function is gonna help us with that. First step is to load the dataset. Since this dataset is already available in our sklearn library, we will just call the function load iris, which will load all the required dataset into this iris variable. We will run this cell. Next step is to segregate the data between dependent and independent variable. By design, on y we represent all the dependent variables and x will represent all the independent variables. In more layman terms, y is what we are going to predict and x is what we are going to use for the prediction. Next we are trying to explore what's inside y and what's inside x. We are just trying to print it and see what it contains. Clearly y contains numerical variables, so each numerical variable inside y represents the category of a flower. So we have 0, 1 and 2. So basically we have three category of flowers represented by each numeric digit here. Similarly, inside x we have features of the flower: petal length, petal width, sepal length and sepal width. It's in a form of numpy array basically. The step is to use train test split. This is very crucial part, as here we divide the data into train and test part. Again, this train test split is by default function from sklearn package as well, so we can use that function itself. So we just supply the variables we want: x train, x test, y train, y test, and inside train test split we will supply what are the numpy variables we are trying to split. So we have already segregated our data into x and y form, so we'll supply it, and voila, our data has been separated into x train, x test, y train and y test. Next step is to just create a random forest classifier with number of estimators of 500. Again, there are many parameters here which you can hyper tune, but now we are gonna concentrate on only one parameter, which is number of estimators. In next video we are gonna cover a more detailed of how to hyper tune these hyperparameters. So now let's just create a model, and once we run it, our model is ready. It's pretty much easy. It's hardly 5 to 6 lines of code. Now we have created our model, but how do we test whether our model is good or bad? So again, sklearn library is here to our rescue. It has already a function of a score which will tell us how accurate is our model. So once we run a score on our model using x test and y test, it will tell, okay, my model is 93% accurate. So basically we can understand by this result is that using these number of estimators as 500, we can get a model of 93% accuracy. And again, if we want to predict something from this model, this is how we predict. Suppose we create a sample data with variables like petal length of 5.1, petal width of 3.8, sepal length of 1.5 and sepal width of 0.3, and we will supply this sample inside our random forest like we are supplying here, and we will try to predict it. Okay, so so we just have to run this cell one more time. Yeah, so it has predicted it belongs to category 0. We can manually check it from here because I have copied it from here. So 5.0, 3.5, 1.4 and 0.2 belongs to category 0. So this is random forest for you guys. It's super easy and super intuitive to use. In next video we are gonna use hyperparameter tuning on the same data set. Till then, bye bye.